With number 9 on Ohm's Law worksheet, we have a different problem that we haven't encountered before. In this particular problem, there is a small lamp. It's an LED lamp, but this particular lamp is restricted. It can only operate at 5 volts and 3 milliamp. And milliamp is the same thing as 3 thousandths of 1 amp. So this is actually really common, and the problem in this particular circuit is that it's an automotive circuit, so it is always at 12 volts. So this lamp is going to be involved in our automotive circuit, but if we supply 12 volts to this LED, it is going to burn the LED out. It's too much electrical pressure for it. So we need to add a resistor. But how are we going to do that? We have a source voltage that is much higher than its actual use voltage. In this case, it is another type of series circuit wherein we're using a lower voltage tool. We just need to find out what this is. And the way to do that is take your voltage. I'm going to call voltage 1 minus voltage 2. And that is going to be 12 volts minus 5 volts. And that will give us the voltage needed to run Ohm's law through. At this point, 12 minus 5 is 7 volts. Now you can solve using 7 volts and 3 milliamps and solve to find out what your resistance value needs to be for this circuit. Number 10, to finish out, is what's called a parallel circuit. And the arrangement starts off looking the same. We have our battery source, we have our power, but instead of two objects or loads in series with each other, they are running parallel. And we see this type of arrangement in computer systems and especially alternating current, house lights and things along that line, outlets. And when we try to figure out what the resistance is in this circuit, I can't add them up like we did with